Okay, 8.3 is called solving right triangles, and by the end of the video, you should be able to use trig ratios to find angle measures. Previously in 8.2, we found side lengths, and today we're going to find angle measures. And a really, really important thing for you to remember is that when we're solving for angle measures, I can write this down, use the inverse trig functions. So examples of those are something that look like this. It looks like sine -1, but we call this inverse sine, or inverse cosine, or inverse tangent. And I'll let you know what that means in just a second. But that's super important that you remember whenever we're trying to find angle measures, you're going to use one of these three things. Okay. Oh man, I don't know why this one. Oh, okay. It says use the trig ratio. So the first thing you're going to do is identify angles from trigonometric ratios. And this first question says use the trig ratio. Should be right here. Cosine A equals 24/25 to determine which angle of the triangle is angle A. So if you look at this picture, there is no angle A, but there is angle 1 and angle 2 and then 90 degrees. I'll give you a huge hint. Majority of the time, your answer should not be the 90 degrees. So either angle A is going to be here for angle 1, or it's going to be here for angle 2. And to determine where the A is, we have to look at the fact that cosine of that angle is 24/25. So cosine, remember, it's SOH TOA, or you could write it like this, SOH TOA. So cosine stands for adjacent over hypotenuse. So if angle 1 was right, if A was at angle 1, that means cosine of angle 1 is adjacent, would be 1.4, and hypotenuse is going to be always going to be 5 because it's across from 90 degrees. So that's what cosine would be if angle A was from angle 1. If angle A was at number 2, then the cosine of that, well, this time the adjacent side would be 4.8 because, again, it would be touching the angle. And a hypotenuse is still going to be 5, so it would be 4.8/5. And to figure out which one it is, we're going to look at the decimals. So if you look at 24 divided by 25, that as a decimal is 0.96. So one of these has to be 0.96, and whichever one is going to be the answer. So I think it's going to be 4.8/5 because those numbers are really close to each other. So when I put it in my calculator, I do get 0.96. So since these have the same decimals, that means that angle A has to be at number 2. So to write that as your final answer, you'd say angle A equals angle 2. And so now I know that this is A for my triangle and it's not over here. Okay, number 2, same kind of question, determine which angle of the triangle is angle A, given knowing that sine of A has to be 8/17. So if sine stands for opposite over hypotenuse, so if A was here, that means the sine of angle 1 would have to be opposite 27 over a hypotenuse. Hypotenuse is always across from 90 degrees, so over 30.6. That's if it was over here. If it was over here, let's see, sine of angle 2. This time the opposite side would be 14.4, and the hypotenuse is going to stay the same, so that would be 30.6. So now we just look at the decimals. 8 divided by 17 is 0.47. And notice 8's like less than half of 17. These are really close to each other. 14.4 is really close to 15. 15's about half of 30.6. So I'm going to try this one. You can pop it into your calculator without even thinking, but I'm going to do less work and say this is also 0.47. So since these have the same decimals, that means that angle 2 has to be angle A. So again, your final answer would be angle A equals angle 2. Okay, so you're going to do number 3. I'm going to check it in class. And you're going to reflect on what did you just learn. And I would like a complete sentence at least, please. So what did we just figure out how to do? I could tell you that we just figured out how to use trig ratios to figure out which angle something has to be in a triangle. Okay, second thing we're going to do, this is the best part of what we're doing today. This is really fun for me. It says the second part is solving right triangles. So we want to find the unknown angle measures, and we want to we also want to find side lengths. So whenever I say solve the right triangle, that means find everything you possibly can about this triangle. So I want you to find side lengths, which is what we worked on yesterday. And the new thing is I want you to find angle measures. So let's do side lengths first, since that's something we already know how to do. So I'll do 5 and 6 and 7 with you guys, and then we're going to go back and do 4, 8, and 9. Okay? So number 5 wants you to find side length EF. Side length EF. So I'm going to call this X for now. And we know the information they give us, because we only use the information they give us. We don't want to use anything else. We know this is 58 degrees and that's 14. So, according to this 58 degrees, we have an opposite side, and this is the hypotenuse, so this one has to be adjacent. So which trig function talks about opposite and adjacent? If you don't remember, so SOHCAHTOA. Oh, it's tan. So our equation is going to be tan of the angle, which is 58 degrees, equals opposite over adjacent. So equals 14 over x. And then we're going to solve. Remember there's shortcut. Since x is on bottom, you just flip-flop the two. And in your calculator, all you have to put is x equals 14 over tan 58. 14 divided by tan 58. I get that x equals 8 point to the nearest, hundredths. So 8.75. That's what I get for x. Okay, so we just solved for this side length. The next thing says to find df. You can use trigonometry again. Totally can use trigonometry. Wouldn't hurt my feelings. However, if you just use Pythagorean theorem, it won't get you an exact answer. It would be more precise if you did trig, but it's fine. So if you used 8.75 here, you could just say a squared plus b squared equals c squared. And we already know this side's 8.75, so 8.75 squared plus 14 squared has to equal the hypotenuse squared. So this is c. Okay, so 8.75 squared plus 14 squared. I get that the hypotenuse is about 16.51. So check your work and make sure you know how to use your calculator and you remember how to do Pythagorean theorem. You should get that df equals 16.51. So just to recap, we got 8.75 for this one, and we got 16.51 for this one. Now I'm going to do this same problem one more time. I'm going to show you how you can use trigonometry to figure out that the hypotenuse is 16.51. So again, you're only going to use the information they've given you. So we want to use this 58 degrees. We want to use the 14, which we've already said is opposite. And we want to use this, this side, which we know is the hypotenuse. So we're going to have to use something with the opposite and the hypotenuse, which would be sine. So your equation this time would be sine of the angle, which is 58 degrees, equals opposite over hypotenuse. And then since it's on the bottom, the variable's on the bottom, all you do is flip-flop. So it would be h equals 14 over sine 58. Pop that into your calculator. And oh my goodness, I get that my answer is 16.51. Ding, 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 ding. We got the same answer. So you can use Pythagorean theorem if you really want to, or you can use trigonometry if you really want to. This is going to be a more exact answer than this one. Okay, so same thing for number 7. We want to find what ST is. I'll call it X. We don't even have to do trigonometry. We can just use Pythagorean theorem. So x squared plus 5 squared equals 5.7 squared. Let's see. And I get that the answer is 2.74. So this answer is 2.74. Make sure You remember how to use Pythagorean's theorem. Okay, so for this triangle and this triangle, we found all the 3 side lengths that we possibly can. Make sure you have this written down. Pause it if you need to. I'm going to erase all this stuff because the next part is something we have not learned how to do yet. And that is to not find side lengths. We're good at that now. We need to find angle measures. So if you notice, I'm going back. Okay. We're only going to use the information that they originally gave us. We're not going to use any of our answers because that means our answers are going to be off just a little bit. So angle D. I want to figure out what angle D is. Oh my goodness, this is going to be super easy. We know this is 90 degrees and we know that this is 58 degrees. So if we add them up and subtract it from 180, well, so 90 plus 58 plus angle D has to equal 180 degrees. Subtract both, subtract 90, subtract 90. Really, all you have to do is take 58 and subtract it from 90 because 58 plus angle D is going to always equal 90 degrees. If this is 90 degrees, that means these 2 angles have to add up to be 90 degrees. That's easier for me to do in my head. Like I can take 90 and subtract 58 and know, okay, well that's 32 degrees. It's a little bit harder for me to add them up and subtract it from 180. But if you're a super rock star like that, by all means, you can do that. So angle D equals 32 degrees. That one was a piece of cake. Not a problem. This one is where we're going to get a little bit difficult. And if you need to rewind and watch this again, you're more than welcome to because I have to kind of speed up here. Angle R. Notice there's no angles in this one. So what we're going to do is we're going to use inverse trig. So that means either sine -1, cosine -1, or tan -1. We're going to set up our equation just like we usually do. We know that the 5 and the 5.7 is the information we have. We know 5.7 is the hypotenuse because it's across from the 90, and the 5 is the adjacent because it's touching it. So we're going to have to use cosine since it's adjacent and hypotenuse. So your equation is cosine of angle R equals adjacent over hypotenuse. Now this is your variable right here. You can't divide by R. But what you can do is do the inverse. So in your calculator, you literally press this button and pop this. It'll open up a parentheses or open up a parentheses if it didn't. And I'll show you how to do this in your calculator tomorrow. But there is a cosine button. There should be a cosine button on your scientific calculator, and behind the cosine button will be a cosine -1 button. That's the inverse cosine. When you pop this into your calculator correctly, you should get angle R equals 20, we're going to round to the nearest degree, 29 degrees. So try it on your calculator right now and see if you get 29 degrees. If you do, awesome. If you don't, we'll work on it in class tomorrow. So now going back, we know this is 29 degrees. Well, this is 90 degrees. All you have to do is subtract. You can use trigonometry if you want to. You don't have to. You just subtract and you get 61 degrees. If you wanted to use trig, I'll do it one more time really fast for you. Use the information that they have given you, excuse me. So this time we want to know what angle T is. Well, this would be considered the opposite side, and this is still considered the hypotenuse. So the trig function that you would use, because it talks about opposite and hypotenuse, would be sine. So sine of angle T equals opposite over hypotenuse. And to solve, all you do is do the inverse sine. So you literally pop this into your calculator, and it'll tell you that it is 61 degrees. Try it and see if it works. If not, I will show you another way to do it tomorrow in class. So reflect. You get to do 10, 11, and 12, and I want you to write down what's one thing you learned from this video. Okay, I'll check it tomorrow in class.